All right, let's dive in. We are going on a journey deep inside what is honestly one of the most complex machines ever built by humans. We're going to peel back the layers on Facebook's infrastructure and see how it all works, just by following the path of one single, simple click. But first, you have to appreciate the scale we're dealing with. Look at that number. 3 billion users. That's mind-boggling. We're not talking about a website anymore. This is a planet-sized distributed system. And every single thing we're about to talk about is designed to handle that insane load. You've done it thousands of times, right? You tap that like button. It seems so simple. But that one tap kicks off this incredible high-speed chase across the entire globe. So that's what we're going to do. We're going to follow the life of a single like and uncover the secrets of how this all works. Okay, so let's start the journey. And here's the first surprise. It doesn't begin at some massive centralized data center. Nope. It starts right at the network's edge, in a location physically close to you. This whole system is absolutely obsessed with speed, with cutting down every possible millisecond of delay. The magic starts the very instant you tap. Your app doesn't wait around for some server halfway across the world to say, okay, got it. No way. It just immediately turns that button blue. This is a really clever trick called an optimistic update. It makes the app feel instantaneous, completely hiding that network lag before your request has even left your phone. So here's what happens in those first few moments. Your phone shoots off a tiny little data packet, but it's not going all the way to a main data center. First, it hits a local point of presence, or POP. The POP does all the initial heavy lifting, the security handshakes and all that, and then it sends your like on its way through Facebook's own private fiber optic superhighway. The whole goal? To wage war on latency. So what is a POP, really? Well, think of it like a local branch of a massive global bank. It handles all the initial paperwork, it checks your ID, it gets everything ready to go right there in your neighborhood. That way, the headquarters, the huge data centers, can focus on the really big, important stuff without getting bogged down. All right, phase one complete. Our little light has safely arrived at a massive data center. Now for the most critical step of all, making it a permanent part of the social graph. That's the digital map of literally every connection between every person, post, and photo on Facebook. But here's the thing, writing directly to a traditional database is just too slow. So instead, the system talks to something called Tau. Tau is this amazing, custom-built, hyper-fast caching layer. It's basically the social graph's head librarian. It knows exactly where every single piece of information is, and it can grab it or update it in a flash. And this is so key to understanding the whole system's philosophy. Speed first. As you can see, your like gets written to that super fast Tao cache right away, creating that digital connection. Then, in a totally separate process, the like count gets updated. And only after all of that, kind of in the background, does the system worry about saving it to a permanent database. You get that instant feedback, and the system handles the slow stuff later. Okay, but wait, we just created a huge problem. We wrote the like to one data center in, say, Oregon. What about all the other data centers in all the little caches all over the world? They're all holding old, stale data. They think the photo has one less like than it actually does. How do you fix that? You use a system with a fantastic name, McSqueal. McSqueal's job is to just sit there and watch the database logs. The second it sees your like get saved for good, it acts like a global town crier. It just screams, hey, this photo has a new like, to every single cache server on the entire planet, telling them your data is old, get rid of it. All right, quick recap. The like is saved, and the world knows about it. But the journey isn't over, not even close. Your click isn't just about changing a number on a photo. It's a powerful signal, and that signal now has to ripple across the entire platform, especially to the news feeds of all your friends. That ripple effect is powered by a system called Scribe. The best way to think of Scribe is as the central nervous system for all of Facebook. It's this enormous logging pipeline that sees every single thing you do, every click, every view, every like, and it streams that information in real time to all the other parts of the system that need it. It's the glue that connects everything. Now, this brings us to a huge, fundamental question that every social network has to answer. How do you build a feed? Do you use a push model, where the second you post something, the system works really hard to push it into the feeds of all your friends? That makes reading a feed super fast, but posting itself can be slow, especially if you're a celebrity with millions of followers. Or Do you use a poll model, where posting is instant and the real work happens when your friends open their app and their phone has to pull all the latest stuff?
And Facebook, they went with the poll model. For a system that's swallowing billions of actions a day, making the act of you liking something, as fast as humanly possible is everything. So your like gets logged by Scribe, and then it just kind of sits in another system called Multifeed, waiting. It just waits until the next time your friends open their app. Only then does the system pull that like in as one of the thousands of signals to build their feed on the fly. And that leads us to the final piece of the puzzle. And honestly, it might be the most mind-bending part of this whole thing. We've seen how your like gets stored and shared. Now let's see how it gets used as a lesson for one of the biggest AI systems on the planet. This is what's called the ranking funnel. When your friend opens their feed, the system might have over 2,000 potential stories it could show them. It's impossible to analyze them all with a powerful AI. It would take forever. So it uses this funnel. It starts by quickly filtering out anything bad, then uses simple models to get from 2,000 down to 500, then better models to get to 100, and only then, at the very bottom, does it use these huge, deep neural networks on the last handful of items to pick the perfect order. But what's the goal here? What's the AI actually trying to do? It's not just about getting you to click on stuff. The real goal is a concept they call Meaningful Social Interactions, or MSI. The algorithm gives way more points to things that actually start a conversation, like a long, thoughtful comment, than it does to a simple, passive like. It's trying to predict what will make you and your friends actually connect with each other.
And just like that, your like is transformed. It's not just an action anymore, it's a feature. It's a new piece of training data for that giant ranking AI. Tonight, when all the machine learning models get retrained on all the data from today, your little click will teach the system that you and people like you are interested in this kind of thing. The feedback loop is complete.
Okay, we've followed the single like from your fingertip across the globe and right into the brain of a massive AI. So after all that, what is the one big secret that makes this whole thing hang together? It really comes down to this one quote from the engineers who built it. The core insight is the rigorous decoupling of the write path from the read path. That's the secret sauce.
So the best way to think about it is that Facebook isn't one system. It's two completely separate, massive systems running at the same time. You've got the write path, whose only job is to take in your data, your like, and make sure it's stored safely and accurately. Then you've got the read path, whose only job is to build a unique, personalized feed for you as fast as possible. And they're glued together by those pipelines like Scribe, which lets each side do its own thing without slowing the other one down.
And that leaves us with this one last, pretty deep thought. We're seeing this massive shift away from systems that are built with a bunch of static rules to systems that are constantly learning and optimizing themselves based on real-time data. And as AI works its way deeper into every single layer of these systems, you have to ask, what does it mean when a system is no longer just configured, but it actually begins to learn?